This is section 1.4 on experimental design and ethics, and we are going to start out with some vocabulary. And so we're going to go through these definitions here fairly rapid fire. Make sure you can pause the video if you need some more time to write these down, of course, and use these definitions in combination with what you're seeing in the textbook, or other definitions that you're finding online. Because there are a lot of good resources out there that can explain things really well. If you want me to take a look at some definition that you find, just send it my way and I'll take a look at it and see maybe how it matches up to what we have here. And it's good. All right, so we're going to start our definitions here looking at some different types of variables. The first one is the explanatory variable. This is the variable that may influence an outcome in an experiment. It's manipulated by researchers, and it's also sometimes called the independent variable. Okay, that independent variable comes up fairly often, so we'll keep that highlighted there. But an explanatory variable is, you're seeking to look at this thing as an explanation for some outcome. So we know some outcome has been occurring. We want to know what's causing it. We manipulate or change things in the explanatory variable realm here as part of our experiment to see if they can explain the outcome that we're seeing. Okay. And that outcome is the next definition that we're going to look at here, the response variable. So the response variable is the variable that is affected and measured for changes in an experiment. It responds to the experiment process. And this is also sometimes called a dependent variable. Okay, so in an experiment, we're hopefully seeking to show some sort of cause and effect type of relationship between these two variables. And we want to show whether or not the explanatory variable that we're looking at can explain the response variable. So response is like the outcome, explanatory is our explanation of that outcome. And we want to see if this link between the two is really there. Is there a causal connection, or are they just maybe correlated somehow? That's what we want to find out. Okay, now our next type of variable is a lurking variable. So these are variables that are lurking and hiding around the edges of your experiment. And so these are additional variables that are not being studied, but they could still potentially affect the outcome. These are also called confounding variables. Okay, and we have seen that term confounding briefly as in connection with the idea that sometimes things, life, experiments are so complicated. There's so many factors that go into them that sometimes we're not entirely sure where the outcome is coming from, what can really explain that outcome. So lurking variables are the ones hiding in the background and potentially giving a response here, causing some effect on the response variable, but they're not the one that we were trying to study. They're not the explanatory variable. So both of these can influence the response. This is the one we care about and want to study. These, well, we also care about them because we want to see if we're getting some weird result because of a lurking variable. All right, so those are some main variable types there. Now, in other aspects of experimental design, we have treatments, which these are just different, we could call them values or components of the explanatory variable. Um, Researchers are going to decide which treatments to apply. And what this basically means is what are we going to change or test in this experiment? So we're going to need to manipulate our explanatory variable somehow to see if it is really causing the response that we're looking at. And treatments are how we're going to account for that. Like if we apply a certain treatment, does it cause a response? If we apply this other treatment, does it cause a response? That type of thing. So treatments are going to be our different, I think values of that explanatory variable is a good way to put it. There might be some other good definitions out there though. Then we have our experimental units, and these are participants or subjects in the experiment. This is an individual or an object being measured. And a lot of the time we think about experiments being done with groups of people or studies, things like that. But we got to remember that it can also be things other than people, like objects, other things. So an experimental unit sounds a little bit impersonal, but it can refer to a person or it can refer to whatever type of object that's being studied and measured. Okay, now we have random assignment, and this is really getting into the setup of the experiment. This is when researchers organize experimental units, or participants, into treatment groups using random methods. So here, random assignment is where we, the researchers, are going to decide who goes into what group. And we're going to use random methods like the random sampling methods that we've been looking at. So simple random sampling, systematic, stratified, cluster, that type of good stuff. You could use those to do random assignment. Probably simple random sampling would be a good one for experimental design. I'm just thinking off the top of my head, but in some random way, we are going to assign our participants into groups to receive different treatments. Okay, so one of those groups is going to be the control group. And that's the group that's going to get an inactive treatment or a placebo, which we'll define in a second. So the control group is the group that essentially you can think of it as like we're leaving them alone and not doing anything new to them. They're not receiving the new active treatment that's going to hopefully change things and cause a response. If our experiment works out generally as planned, the control group hopefully would not have an effect that we see in our results. Okay, so the control group is very important, and so is the idea of a placebo. So again, a placebo is an inactive treatment that cannot influence the response variable. So for example, one of the common ones in medicine is to give people in the control group a sugar pill instead of the new treatment pill that you're trying to study. So we want to see, does our treatment, our new pill do anything? Or do the people who get the new drug, do they have just about the same results as people who got a pill made of sugar? So that's a kind of a classic example there. Now, there is something called the placebo effect, which you may or may not have heard of. It's kind of a common phrase out in the world. And the placebo effect is when sometimes the placebo can actually result in a little bit of an effect if people really believe in it. Um, so if they want it to work so much, it can actually cause some tiny results. Um, or sometimes people, if they believe that the placebo is doing something for them, they may change some other behavior in their lives that could become a lurking variable and have an impact on our study. So, especially when we're working with humans, things can get a little complicated. Um, but just remember that the placebo is the inactive treatment. So the control group is going to get a placebo. All right, last idea in our definitions here is the idea of blinding. And an experiment is called blind when patients or participants don't know which treatment group they're in. So this does apply to humans. Um, so if people know that they're in the control group, or if people know that they're in the group getting a active treatment, sometimes that can have a disproportionate impact on their response. Um, so yeah, if someone's in the control group, they might just totally give up on the experiments, and that's not good. So we generally like to see experiments that have been blinded. We don't really want the participants to know which group they're in because that can have an impact or a bias as far as our results go. And then to take it up a level, we can also have a double blind experiment. This is considered to be a pretty good gold standard here. And in a double blind experiment, neither the patients nor the researchers know which treatment group a patient is in. This is concealed or unknown on both sides of the experiment there. So sometimes people wonder, like, how does that happen? Don't the researchers have to know? And no, not necessarily. Since we're using random assignment methods to put patients into different groups, you can do this on the computer or through a third party, um, so that the researchers don't see which groups patients get put into. The patients could just be given a random number assigned to their name. Those can get all mixed up. And then you can use a computer to randomly assign them to control or treatment groups. And yeah, the researchers really don't know which group a patient is in. And that's considered good because there can be bias on both sides. If patients know that they're in a certain group, sometimes they'll behave differently. If researchers know that a patient is in a certain group, sometimes the researchers will behave differently. It's just humans. So having a double blind experiment gives us some protection against human emotions and biases and things like that. So that's generally a good thing to have.